properties of integrals. The first one, we say if you have a definite integral, limit a from b, fx dx equals c, for example, then if you switch the integral b to a, you get the same answer with a negative sign. And if you have definite integral, a starting point and ending point same, then this integral is 0. We know that the integration gives us area under a function. If I start a and stop at a, so the length is 0. So that's why this integral is 0. Okay, now finding a function from derivatives. Say that I gave you a function f prime x is 2x minus 3 over x, and also given f1 is 3. So you need to find f5. To get f5, first you need to see what is fx. To get fx, we need to integrate f prime x. So f prime was 2x minus 3 over x. Take the integral. You know that 2x will give you just x squared. Just verify that you understand this. Because 2 times the integral of x is x squared over 2. 2 to cancel out. And the negative 3 is a constant we leave there. 1 over x gives me natural log of x plus c. Now we'll be using condition f1 is 3. So first we see what is my f1 in my new result. So f of x is x squared minus 3 natural log of x plus c. So f1 will be all x replaced by 1. So you get 1 squared minus 3 natural log of 1 plus c. And as you know, natural log of 1 is 0. So then you get f1 is already given 3. So 1 minus 3 times 0 plus c. So that means 3 equals 1 plus c. If you subtract 1 both sides, you get c equals 2. So then my function is x squared minus 3 natural log of x plus 2. Now if you want to find f5, just replace x by 5. And you get 27 minus 3 natural log of 5. You can keep this one as exact answer. Or if you want to get a decimal, then you can put it in the calculator. Area under a curve and between two curves. So first we are given f of x is 3x squared plus 2, and between x equals 2 and x equals 4. We want to see what is the area. So as you see in the graph, this is made in Desmos. So 3x squared plus 2 is the parabolic graph, and we are getting ordinates from 2 to 4. So this area is defined by this integration, 2 to 4 fx dx. And our function f of x is 3x squared plus 2. And then just like regular definite integral, we integrate the function. So 3x squared integration gives me x to the 3, and 2 gives me 2x. And the limit goes from 2 to 4. So first we plug 4 and then subtract when you plug 2 for x. So the simplified version is 40. And the next one, we take area between two curves now. One curve is 9x minus x squared, and the other one is gx equals x. Let's see the graph in Desmos. So 9x minus x squared is the top graph, upside down parabolic graph. And then the next one is y equals x, or gx is x, is the straight line passing through the origin. So between these two, we have the bounded area. Now the formation of integration for the area will be, first you write the top function minus the bottom function. So top function is 9x minus x squared, and the function below is x, so we subtract it. And then integrate. So you get 9x squared over 2 minus x to the 3 over 3 minus x squared over 2, and integration limit 0 to 8. So first we plug 8, and then when you plug 0, so everything goes to 0. So the final form of this one is 65.33 approximately. Or you can write this one, exact answer will be 65 1/3. Thank you. Next, we are going to Riemann sum concept. So that you are given a function f of x is 4x squared minus 4, and the interval given 2 to 8, and we are saying that we'll make two divisions, n equals 2. So then the width of the rectangle will be delta x, which is b minus a over n. So you need to calculate the Riemann sum for the left hand and right hand approximation. So we find out delta x, which is 8 minus 2 over 2, n is 2, that's why. So we got 3. And now our boundary point, first x0 is the starting point 2, then each point will increase by 3. Okay, so we got x0 is 2, x1 is 5, and x2 is 8. So I'm looking for left Riemann sum. So left Riemann sum will start from x0, and it goes to x1. So you have delta x, evaluate the function at 2 and 5, and then that will give you 348, your left Riemann sum estimation. And the right Riemann sum now starts from x1, which is 5 and 8. And then we got this one. Thank you. And you can see the graph here. And the points are like this. We are going from 1 through, we are going from 2 to 8. And then every 3 units going. So 2, 5, and 8.